because we know our brain can run on one banana. If we would like to do the same computation as in our brain, in the digital computer, then you would need a small nuclear plant.
Thank you for coming in.
Thank you for the invitation.
I'm slightly intimidated, and
Not necessarily.
I don't know really anything about what we're going to talk about, so I'm going to ask lots of silly questions. If they are really silly, please just humour me. I also want to make sure that I fully capture yourself, and I've got some notes, and I'm going to basically sit and read them because I don't want to get anything wrong. So, PhD in neuroscience, 20 and counting peer-reviewed articles in neuroscience, brain imaging, and most recently on biocomputing. Currently strategic advisory to Final Spark, which is what we're going to talk about, which is focused on effectively commercializing a neuro-platform for remote living neuron computation, which sounds very interesting. Founder of Sync, a mental wellness app, speaker on podcasts, speaker on panels, scientist come entrepreneur come tech commercialization advisor, and everything in between. Is that about right?
Thank you very much. It's very good. Thank you. Very nice introduction.
Thank you. Before we dive into Final Spark, and I'm really curious, and I have a lot of questions, but can we just start with your journey and your evolution? Because traditional science and PhD, etc., into where you are now, can you just give us some detail of what that looks like and how that's played out for you over the course of your career?
So I started with biology. I did PhD in neuroscience in the Netherlands. I was always fascinated with brain and anything related. So that's why I did neuroscience and indeed brain imaging. So that was my specialization. And after I landed in London at King's College, I was doing also some medical imaging research. And London is a great place for networking and for discovering a new career. So I had opportunity, to think what I can do next, because I always wanted to leave academia and I wanted to see what is outside. What else I can find. But I had no idea about this. I wanted maybe to work on some big corporation. I didn't know actually what to do, but I was going to many meetups, some networking events, and I discovered my way to the startups. And I started to work in London in some software company, which was doing a medical imaging service. And this is how I learned about artificial intelligence. And I became fascinated with this. About what you can do with AI. That was time before ChatGPT, so all the new little things in image analysis, but also some first development in text analysis. That was really impressive what AI can do, and I started to work fully on commercial applications of AI and outside medical imaging. And this is why I also found the Final Spark founders on one of the conferences in London, which was very useful, and I became fascinated with this because it was a combination of biology and engineering, so two topics which were interesting for me. So engineering, I'm doing more on the commercial side, and neuroscience I know from the basic side, from the lab, but it's a great combination of these two topics. So Final Spark is trying to build computers from living neurons. So these are the same living neurons which we have in our heads, and we try to put them in the lab on the electrodes, and we try to program them as living computers. So that's in a nutshell the journey to this.
We'll definitely get into biocomputing, but so you mentioned you're very interested in the brain and studying the brain, etc. What is it that fascinates you about the brain?
Well, I just thought, someone gave me such advice when I was still a master student. I was doing some projects, and someone told me just think about which part of the medical topic is the most fascinating. What would you really like to, if you could choose anything? And then I thought, okay, brain is the best because mind is really, powerful, and it's also a mystery. So we still don't know actually how it really works, which is also a challenge for a biocomputer. So it's a lot of secrets, but also just I think that the way how brain works is the most fascinating. Maybe because we are also curious about our own mind and our own brain, how we can enhance, how we can maybe make it better. So it's just the most interesting topic.
And now you're, I guess, at the intersection of the brain and then technology and how the two are going to fuse together. So you're in biocomputing. Mm-hmm. What is that? What high level, like what does that actually mean?
So biocomputing is making computation on living neurons. So this is a new field, and also, the wording is not fully established. So you can actually find on the internet, you can find biocomputing or wetware computing or organoid intelligence. So there are different words which are describing the same thing, because it's so new that people still didn't establish like which vocabulary will be 100% for this. And this is a new thing which is active maybe for 10 years. Because before it was not possible technically, because for example today we can get huge quantities of living neurons from human skin. So you don't have to kill anyone to get neurons. Before, like 20 or 30 years ago in the laboratory, if you wanted to have real neurons, usually you had to sacrifice some animals to take them from the head. So today it's possible to get neurons from human skin. And you can play with them if you have some crazy ideas, because it wouldn't be ethical maybe to sacrifice animals for this research. And we are trying to program neurons. So what does it mean? We have them on electrodes, and we sending them electrical signals, and we receive the response, because neurons are constantly active. So they are transmitting information via electrical activity. And you can also induce neurons with some chemical substances. So we also try to do this. So we basically try to program them with electrical or chemical stimulations so that they can change the behavior, so that in the future we can program them as a computer chip. So that's the idea. So that's biocomputing.
Okay. And when you say that you're taking the human neurons from skin, so is that through stem cells effectively?
Yes, because you can reprogram the cells. There was a Nobel Prize for this around 15 years ago. And when you take skin cells, you can make from them stem cells. And from the stem cells, you can take, theoretically, you could produce any type of cells from the human body.
I saw a study actually a couple of years ago. I think is it Bruce Lipton, or who's an expert in stem cell, but he was talking about taking a single stem cell, and then it duplicated itself until they had 30,000 stem cells, split them into 10, into 3 equal parts, and then introduced different chemical substances that would be a replication of like hormones in the body effectively that would come from the brain. And I think one of the stem cells one of the petri dishes produced bone, one produced fat, one produced tissue or muscle, sorry. And he was talking about how the input and the chemical balance in your bloodstream and the hormone response to like emotional triggers and that sort of thing can have a direct impact on how the stem cells grow and what they produce effectively. So are you trying to mimic those sort of impulses? When you say you're introducing chemicals and that sort of thing, you're introducing like hormones effectively that would then mitigate how the stem cells respond?
Yes, so actually when you have stem cells, you can treat them with some special substances, not necessarily hormones. And you basically try to change the gene expression, because every cell in your body has the same genome, but not all of the genes are active. So if you activate some part of genes, you can get maybe skin cells. If you activate another type of genes, maybe you get some other cells or maybe also neurons. So basically what you try to do is you try to change which genes will be active in the cells, so the cell can become a neuron.
Is there any similarity between that and CRISPR, which I understand is like gene editing?
No, actually, no. We don't do any CRISPR. We could actually theoretically do this if we would like to produce some special neurons. But at this stage, we don't think about this yet. Right. Because now we just need healthy neurons to do some basic research. But in the future, we could think about making some super neurons, maybe, which will have better properties. But that's very theoretical. It's for the far future.
So how did you... I mean, I want to talk about the final part, but like, how did you come to be involved with the company?
So how I started. So as I mentioned, I was in London and I had my first job in industry and I was going for many meetups and conferences and I was at AI Summit in London and I met there the founders of Final Spark and I thought it's very impressive what they do because they're engineers. So they are Fred Jordan and Martin Kutter. These are the founders from Switzerland. And they are basically, they have PhD in signal processing, but they went to biology. So I was very impressed by this, that people, it's not easy to enter a new field and to learn everything from scratch, especially if you have already strong expertise in something else. I became fascinated with the project and I said I would like to get involved.
And where is Final Spark currently on the journey? When was it established? When did you become involved with the business?
So Final Spark was started in 2014, so quite a long time ago. And the objective was to build a thinking machine. Because, that's a dream of many engineers, to build a thinking machine. And they tried a lot with digital technologies until around 2019. They were playing with digital and they realized that it costs too much energy. And such a small startup can never make really like perfect intelligence if you want to rely on digital technologies because they are using a huge amount of energy. And that's why they decided to switch to biology in 2019. They thought, okay, let's stop doing research on digital computing. Maybe we try to change the substrate to compute on something totally different. And they decided for living neurons. Why they did it? Because the company is in Switzerland, so it's very innovative environment. And there are a lot of labs, a lot of people, doing interesting things. And one of our colleagues had already some experience with living neurons in the lab of a very famous professor. So he had some idea about this. And they thought, okay, maybe we try programming living neurons. Because they are also very energy efficient, because we know our brain can run on one banana. If we would like to do the same computation as in our brain in the digital computer, then you would need a small nuclear plant. So they thought, okay, maybe if we will be able to program living neurons, we can have thinking machines, some perfect intelligence, AI, but with much less resources. So that will be much cheaper. And I started to work with Final Spark around 5 years ago. So that's the journey. And we are still doing at the moment fundamental research because it's very difficult challenge, because nobody really knows how brain works, how neurons really encode information and how they process the information on very basic level. We know that neurons are spiking and that information is processed in time and space. So it matters where neurons in your head are active and also at which time. But we don't know really, we cannot translate spikes to some specific information. So we cannot decode this. So this is why if we want to program neurons, then we have to do a lot of trial error experiments. We just don't know what to do, so we try to, you send some electrical signals and you see what's happened, and you send another one, and you try so many different ideas until maybe you get some relationship between input and output. So it's really difficult. So this is why our laboratory is automated, so we can run huge amount of experiments. 24 hours per day and 7 days per week. So that maybe will increase the chance of making it successful.
If we start at the top, so Final Spark as a business, what's the mission? What are the team working towards and the goals? What does good look like for the business over the next 10 years, for example?
So 10 years is a very good timeline because that's exactly how much time we predict we need until we build a biocomputer. So at the moment, we have the laboratory. We do basic research in biocomputing. We have built quite a robust platform for playing with neurons and trying to program them. And our objective for the next 2 to 3 years is learning in vitro. And what does it mean? So we want that neurons can learn something. So that means that we can change connection between them. so we can change the behaviors. So, for example, how they electrical activity. So this would be the foundation for the programming of neurons. If we could change electrical activity as we want, so they could compute something for us. So far, we managed to store 1 bit of information in neurons, so that's very little. It's early beginning, but for the next 2-3 years, we want to crack the learning. And when we achieve this goal, the next goal will be some advanced algorithm, because we would love to be able to compute the same at the same level as digital computers. That would be enough already. They don't have to be better neurons. If it would be the same, that's already a huge success, because neurons are 1 million times more energy efficient than digital computers. And in around 10 years, we expect to build bioservers, which will be huge computers, which will be available remotely for computation. And the whole mission about this is that neurons are energy efficient. And currently AI is using increasing amount of energy. And actually, energy usage is increasing exponentially. And today we can still manage with this, but we can expect that in few years it can be a problem. So we either have to find alternative energy sources or alternative way to computing. And our solution is alternative computing with living neurons, which are 1 million times more energy efficient.
Right. Okay. So if I'm understanding correctly, you're essentially simultaneously running a technology company or a technology environment and then a lab at the same time.
It's you could say one thing. Yes, our lab is yes.
So it's an automated, technology-infused laboratory, effectively.
Yes.
What are like the practical challenges between marrying up those two worlds, if there are any?
So the biggest challenge is in programming neurons, because, as I mentioned, nobody knows how it works. So we have to discover this. So I think the biggest challenges are on the biology side, because engineering, if you plan it well, then it's something what you can achieve. You can be quite sure you can achieve it. But with biology, it's a lot of risk, because every biology experiment might not work. Even if you do everything well, it still might not work, because it's just much maybe bigger failure rate than engineering. So I would say everything on the biology side is challenging in our lab, and for all the team. What is challenging is that you need to combine the knowledge of biology and engineering by one person. So that's also sometimes challenging.
So in your, as the business grows and naturally you're looking to bring in engineers, then I assume, do you need to hire people or to find people that have a split background in terms of biology and engineering? Like you mentioned, the founders came more from a signal processing background, then transitioned to biology. You started in biology. So that must make it really difficult just in terms of finding a talent pool that can support the growth effectively.
Actually, it's getting easier. Because in some countries, we see also in Switzerland, there are new master programs, which are combining actually biology and engineering. And I think it's very interesting for the future. I think it's the future not only for biocomputing, but I believe there are a lot of projects where you need to understand biology, but also be able to be an engineer. So do some hardware and software, because there are a lot of things you can do with this. So I think it's getting easier. And at the moment, actually, we don't have such a problem of hiring, because first we don't have open positions until we don't accept some investors. And another thing is because actually Final Spark is quite popular because some of our work become viral. So there is a lot of articles, a lot of social media posts about us. Not all is true, but a lot of this is true. And many people are actually writing to us, asking if they can work with us or if they can do anything for us. So actually, it's nice that there is not so much problem, because there are people on the world which are interested. But in the future, for sure, we will need more and more people who are able to understand biology and do programming, for sure. Yeah,
I saw some of the YouTube content that's available. The the butterfly in the simulation, that one, which I mean, I sent it to my kids this morning on the train, and they were just like, that's pretty nuts. But if you go to that, say the 10-year horizon, so biocomputing and energy efficiency, what would you perceive? And I fully appreciate it's all very theoretical at the moment, but what are some of the implications for, what are some of the use cases in which the biocomputing can be applied that's going to be a positive impact on wherever it is in society?
So, we believe that it will be great impact, really huge, because we will be able to provide computing power, which will be 1 million times more energy efficient compared to digital computers. So it can have huge impact. It will be just much cheaper also. So we'll be very competitive. And it's difficult to talk about use cases at this stage because, of course, we are still working on the prototype. But by looking at the human brain, we can have some idea where neurons can excel versus digital. Because, of course, we don't think that biological computers can totally replace the digital. That's not what we want to do. We think that it will be rather complementary, because there are some stuff which computers do much better, especially some repetitive, high volume of repetitive actions. Computer can do much better than human brain and neurons. But there are some activities where neurons can be better and much more efficient. And we believe that all the tasks where you use neural networks, which are now digital, like AI, like generative AI also, we believe that all these tasks will be much better done on real neurons than digital. And all the tasks which don't have to be super, super fast. Like, for example, generative AI, generating new ideas or maybe solving some problems. Everything where you don't have to get very fast computation, but maybe some complex computation, which will be done with neurons with much less energy. So that's the use cases which we believe will make sense in the future.
So trending more towards, I guess, like general intelligence or AGI.
Yes.
Would then be able to run on biological neural networks effectively.
Yes, that's what we believe. That would make sense. Yes.
So this might be an incredibly simplistic question, but I'm assuming then there's elements where you're currently developing or building organoids effectively. The goal is for them to become self-learning. Is that right?
Well, maybe.
Could that happen?
Not necessarily self-learning. Maybe. Well, it's hard to say. We would like to be able to program them. So at the moment, you are right. You said we use organoids. So these are such a little round structures which are built at the moment from around 10,000 neurons, and they have 0.5 millimeter of diameter. But this is what we use for testing. And in the future, we actually would like to construct huge structures of neurons, maybe even 100 meters long. So it will be something huge, much bigger than the human brain, and hopefully with much more computational power. And we would like to be able to program them, so to teach them something, so they can perform for us some tasks which are useful.
Right. Okay. So
the same as computer actually is doing today.
So you can program the neural networks effectively to perform tasks that I guess then are being expressed digitally.
Oh, yes. Probably, yes. At the moment, actually, we have everything with digital interface. So actually, we have computer. You can program in Python, programming language. You can program what will be done with the neurons, how you collect the data. Then everything is connected to analog hardware. So you have digital to analog converter, and you transmit everything to an analog signal. And electrical signal is sent to neurons. So neurons are analog, actually. And then when you receive the signal from neurons, then again, you have to transmit this analog signal to digital. So you are right. Everything is connected with the digital interface. And it's possible that also in the future, we will have such a layer of communication that it will be maybe easier to program neurons because you will have a language which you know already, digital, to communicate with them.
Okay. So yes. So your focus within this is commercialization.
Yes.
So let's say that you build your 100-meter long stack of neurons and a biocomputing capability. How do you commercialize that? Like, where are you where are you going with the product, or who's going to leverage it? What are some of the, I guess we're back to use cases, which I know is you don't have them yet, but where does the commerciality come from?
Well, we are actually we have some commercial interest from the first clients, although biocomputing doesn't work yet. But people already pay us to access our laboratory for a research purpose. So I think making this project more popular is already kind of helping with commercialization, because people from all over the world, they can connect with our laboratory remotely, and they can do some experiments on neurons and try to program
where are
them.
they coming from? What's their, is it health? Is it finance? Is it just curiosity and understanding the brain?
No, I would say it's mostly engineering. We have some individuals who are engineers. They want to play. They have some ideas on how to play with neurons. We have also startups, of course, because they're always open to try some new stuff. So some computing startups, and also big companies. Because R&D teams in large corporations, they also try to explore what is on the edge of today's knowledge. So they are also interested. So actually we have clients from all spectrum, from huge companies to individual people. And they are interested already to try, even if it doesn't work yet. But they want to try, to play with neurons, because they believe that in the future biocomputing will work. So they already want to be ahead of the future. So that's for now, for a research purpose. And we imagine that in the future, when we will have these bioservers, they will be very competitive, because you will be able to use computing power, which will be maybe 10 times cheaper than digital hardware. So I'm sure that it will be very attractive for clients.
So this would run, we are kind of stretching my technical knowledge a little bit here, but is going to run as a much more energy efficient and therefore cheaper version of compute.
Yes, absolutely.
Relative to what's currently on the market supporting different large language models.
So you will have, for example, maybe some cloud computing, which will be just cheaper.
Where does ethics come into this? Because when I hear biocomputing, straight away my head goes to you're going to create a brain and put it in someone's head and you can manipulate their emotions with code, which I don't know if that's even realistic, but immediately that's what I think of. I would imagine that when you're dealing with stem cells and neurons and organoids and developing biocomputers, there's going to be ethical considerations somewhere around. Are there external factors that are looking at what you guys are doing, or do you set all of that stuff internally yourselves? Does it even exist?
This is a very good question. We get a lot of questions like that from general public, especially after we become kind of popular on the internet. We started to get a lot of questions about ethics, yes, these are very important questions. But we are actually not experts in ethics, so we decided to reach out to philosophers. Because we think they are much more competent to talk about this. So we are actually actively talking currently with one university in the UK, which will probably start a study about biocomputing, about public perception of biocomputing, and also about some ethical considerations. So these are very important things. And every time you create some new technology, you always have some new questions, because of course this technology didn't exist before, so we didn't have these problems. But now we have to answer them. So we do our best to share the knowledge about biocomputing and to inspire philosophers to think about this, because we want, of course, that our work is accepted by the public, by the society. But there are a lot of questions, especially, we don't really want to, interfere with the human brain. Because some people say that we try to build a brain in a dish, but that's really not what we do, because we only are using building blocks from the brain. So it's like bricks. You can build different buildings, yeah? So we don't try to build little brains. We won't only use the same building blocks as in the head, as in the brain, which are neurons, but to build something totally different. So we don't want to actually interfere with human brain. However, of course, there can be some consequences which are beyond what we do, because when we learn how to program neurons in vitro, so how we can manipulate neurons, for example, electrical stimulation, then theoretically, maybe we will be able also to program neurons in our head, which can be good or bad. So it depends how you use it. So for sure, there are a lot of ethical considerations, and it's necessary, that philosophers and, people who work on ethics, that they prepare for this.
So what would be, let's say the 10-year goal materializes and you've got this 100-meter neural network, etc. Playing devil's advocate a little bit, what are some of the negative implications where if people wanted to manipulate that technical capability, what are the guardrails that need to be in place from a perspective of what you understand of ethics at the moment, or what the universities and philosophers are talking about? What are they concerned about?
Well, I think the main concern at the moment is maybe public perception, because this is something new. It's just every new topic. Also, when you see robots or some other stuff, it usually very often it causes some concern in the public. It's just because it's new.
We don't like change.
Yes,
us
exactly.
Humans.
Because we are used to status quo, and every change is discomfort. So people naturally are, they don't like changes. And I think every technology, also when we see talking robots, people often say that it's disgusting, that it's awful, they don't want to live in such a world. So I think it's just, it's always like that we have to get used to this, to all the new technologies. Some people ask, but this is actually not maybe philosophical question, but many public people, let's say from the general public, people ask about consciousness, which is what if these neurons become conscious, for example. Although this is more, just because we see human neurons, then we try to look at them as they would be humans. But of course, they are just cells. It's not a human body. These are just cells in the lab. But of course, these are important questions. And it's important that philosophers think about this. These are very difficult things.
My brain, when you talked about that, just went straight to Westworld. Did you ever see that show?
No.
So it's like human. It's set in the future, but robots that look like humans and act like humans, but they're running on like pre-programmed loops, and then they develop consciousness.
Yes.
And then it all falls apart really quickly. But when I hear that of like, well, these aren't human, but then there's questions around consciousness.
Yes.
Is there an argument from some people where they would say the brain is the brain and you're playing God a little bit by getting involved? Yes, some people say that.
That's also what we get from the public. But it's every time. We actually play a lot with the biological material already since many years. But it usually helps to solve diseases and many things. But, there's also some research. People try to make superhuman, maybe some genetic modifications so that people can be more intelligent or stuff like that. So actually, I would say many scientists, maybe not always in Europe, but in some remote places, sometimes try to play with biology. So I think what we do is not the most controversial thing you could do.
Is there an application like that? So say that you build a biocomputer and it's stable and energy efficient. Can you go into things like looking at Alzheimer's? Looking at like there must be a huge amount of health implications where people that have, I guess, any neural related issues, there must be so much interest and opportunity from the healthcare community, and you could help a lot of people.
Well, actually, our lab, our platform at the moment is suitable, theoretically, for some neuroscience research, although we don't do this, because our objective is computing. But theoretically, you could use our lab also to work on some disease models, because we can stimulate neurons with electrical stimulation. We can see how they behave very reliably. So yes, we could do some research on that, but we focus on computing.
Because surely things like Parkinson's and stuff like that must be like, there must be so much opportunity there for neuroscientists to study like the use of the technology. Because I've seen some stuff online where people, I can't fully remember what it is, but people with Parkinson's regain a huge amount of motor control from having certain impulses into their brain and that sort of thing, or stimulating certain parts of the brain.
That's interesting. So maybe one day, yes, indeed, when we can program neurons in vitro, maybe we could somehow program neurons of the sick people so they could get better. Yes.
Yeah.
But it's very hypothetical. But
can you do things like I don't know anything about the brain, but say you've got the cerebral cortex and the hippocampus or something like that, or two parts that don't normally go together. Could you theoretically mimic or recreate those parts of the brain and then put them together and see what happens? Is that part of would that be considered a valuable use of time or experiment to sort of go, actually, does that exist, or am I just letting my imagination run away with myself?
At the moment, we have quite, random structures of neurons. But yes, we consider using some specific neurons from specific brain regions. However, it's much better idea to use to combine neurons in such a way like they are also combined in nature. So making some combinations between neurons which normally don't occur, I think it wouldn't make sense too much, because maybe it wouldn't work better.
I'm completely going off on a tangent here. Is it feasible via biocomputing so you mentioned the example of you could manipulate testing when we were talking about ethics to create super intelligent humans. So is that a feasible thing where at some stage in the future, by leveraging biocomputing and tech capability effectively, you could control or negatively or positively impact someone's intelligence or their emotional response to things? Can you turn up and turn down someone's happiness, for example, via biocomputing?
I don't think so, because, at least it's not our objective. But there are some research, how you can stimulate brain to, for example, calm down or be more focused. And there are already some prototypes on this. And maybe the knowledge from biocomputing could help with this, because if we can program neurons, we could maybe learn how to affect neurons. So maybe also how to affect neurons in your head, although it's not the objective of the project. But theoretically, yes.
So the objective at the moment is just
computer
biocomputing.
Yes, absolutely. And this already quite ambitious goal, of course. And we really want to make general purpose computer. That's not to play with the brains of humans. Yes.
Right. Yes. Maybe I'm just going off on a tangent. And then I guess the commercial side of that, as you mentioned, is people wanting to use that computer to harness more energy efficient computing capability.
Yes, absolutely. So for example, maybe we will be able to use some generative AI models, which will be much, much cheaper.
Yeah. So realistically then, any company that's currently interested in leveraging AI and tech will have their own internal use cases via biocomputing.
Absolutely. And I think it's really interesting for big corporations, for the R&D teams, which are really exploring what is on the edge of technology. It's really good to try to see how it works and maybe to do some project. We had such clients.
So what are the biggest challenges currently then for Final Spark to achieving that vision beyond the we don't actually understand how the brain works, so we're just doing lots of tests to see what triggers responses. But outside of that, I guess we live in the real world, so I'm sure money and finances are one thing. What are the big hurdles that Final Spark need to overcome?
So currently we are self-funded, and actually we can keep going like this, let's say unlimited time. However, we are also talking to investors because they could significantly accelerate our development. And we are currently discussing 50 million Swiss francs of investments, which could help us during the next 10 years to accelerate and to build real computers. So that's one of the challenges on which we are working now.
And slightly, I guess, outside of Final Spark, you have, I would imagine, a fairly unique worldview in a sense of the biological background and then the technical awareness, combined with then, a view of commercialization, not specific to biocomputing or Final Spark, but just in general, we're at a very interesting point in time with regard to technology and AI and AGI and everything else. How do you think things play out over the next 5 years or so from more of a societal perspective? Like, how do you think people's lives might change in the next 5 years?
So I think, for sure, a lot of things will change. So for sure, the most important thing at the moment is probably generative AI and the fact that a lot of tasks can be automated. And the opinions are divided how fast it will happen. But I think a lot of jobs will be replaced by automation. And we can already see this, that there is not so many opportunities for junior position because easy tasks can be easily automated. So I think this is a challenge for people who are just graduated around now. I think this is a big challenge. And well, for sure, you can see, and already since few years, you can see such a trend that you need people who have some kind of general overview of the topics and can manage maybe automated tasks. So I think it will go in that direction in many jobs, that you will need people who will have a general understanding of the process of the job, and there will be a lot of automation. So I think this will be going in that direction. And of course, there are many jobs still where you have a lot of human interaction, where I think these jobs are safe. I would expect, but all the intellectual stuff, even actually being an expert or scientist, a lot of things can be maybe we will need much less people to work, and I see this actually on daily basis in everything, that a lot of stuff you can do much faster, and you will need less people.
So is it that because every guest I've had on here is in some way oriented towards technology, and we always inevitably end up talking about AI. And there seems to be two schools of thought. So one is, we're going to need less people. Another is, we'll need the same amount of people, but they'll be infinitely more productive because their capacity to produce is going to go through the roof. If we go on the scenario of there's going to be less jobs, my knee-jerk first reaction is well, what happens to those people?
It's actually hard to predict, to be honest. I think we could expect that there will be new jobs, which we don't imagine yet. Because, 20 years ago, or maybe 50 years ago, you didn't have, I don't know, search engine optimization manager or podcaster. Yeah. There were many jobs which we couldn't imagine. And new technology, eliminated some jobs, but created new ones. What I think what you can expect over, let's say, last 100 years, that the threshold of, let's say, minimum skills for the job is increasing. So you have to be smarter and smarter to do some basic jobs because the easiest stuff were replaced and eliminated from the market. So that's one observation. So I think it may be a little bit more challenging, and we have to keep on learning and using new tools.
Exactly. So where can people find you, get more information, particularly investors? There's a lot of people from finance communities that will watch this. So
that's amazing. Actually, we encourage investors to get in touch if they are interested in Final Spark. It's very easy to get in touch with us. Our website, finalspark.com. We have a lot of forms you can fill in also and send us a message. You can also find all our email addresses on the team section. We have our names and also all the email addresses of the members. And of course, LinkedIn is also a great platform, which we all using for connecting. So it's very easy to get in touch. And with questions also, not only investors, but also anyone who has questions about the project is always very welcome. We get messages every day.
And then I guess finally, it seems like you're really committed and really passionate about Final Spark for the next X amount of years. But what are some of the personal ambitions that you've got within science and biology, within technology? Is everything on Final Spark now, or are there different things that you're going to be looking to do?
Yeah, for the moment, I focus mainly on Final Spark. But I have some ideas also for the future, because we have to constantly learn. Absolutely. We never know what is coming. So I definitely want to stay in technology, in commercialization of the technology, because I think it's very fascinating. It's very powerful. So for the next years, I plan to stay in tech.
Yeah, it's fascinating. And I'll certainly be following the Final Spark journey as best I can. Thank you so much for coming in. I really appreciate it. It's great to meet you. And I guess we're all going to see what the future holds.
Thank you so much.
Thank you.